The World Resources Institute defines global climate change as the debilitation of the Earth's climate system caused by an increase in the concentration of greenhouse gases in the atmosphere, or GHGs. In a nutshell, our atmosphere contains a variety of heat-trapping gases called greenhouse gases, so named because they blanket the Earth, function in a similar fashion to a farmer's greenhouse or a car sitting in the sun. In both cases, the glass lets light pass through, but traps heat energy. This results in temperatures within the greenhouse or car being significantly warmer than temperatures outside. These greenhouse gases form a blanket around the planet that works like the glass of the greenhouse or the car, keeping the Earth's surface about 54 degrees Fahrenheit warmer than it would be without an atmosphere. Greenhouse gases are necessary for life on Earth. Otherwise, our planet would be freezing. The problem occurs when the levels of greenhouse gases sharply increase. It has been occurring at an accelerated rate over the past 200 years. This dramatic increase in greenhouse gases throws off the delicate atmospheric balance and contributes to a host of climatic changes, the most significant being an ever-warming planet, which in turn contributes to the melting of the polar ice caps, rising sea levels, and a dramatic shift in weather patterns. Carbon dioxide, or CO2, is the primary greenhouse gas of interest. As human activities are greatly increasing in concentration in the atmosphere, though there are 6 main greenhouse gases that scientists measure. In the past century, the concentrations of carbon dioxide in the atmosphere has risen almost 30%. Methane levels have more than doubled, and nitrous oxide concentrations have increased by 15%. Furthermore, the growth in atmospheric greenhouse gas concentrations has been progressing at a more rapid rate over time. For example, concentrations of CO2 have increased during the last 40 years at a rate 50% higher than seen in the previous 200 years. That is, a 54 parts per million increase from 1960 to 2000 versus a 36 parts per million increase from 1760 to 1960. What this means is that humans are releasing a variety of greenhouse gases at much higher rates than has happened historically. Additionally, all of these gases differ in their ability to trap heat. Table 3.1 shows 6 primary greenhouse gases having varying lives in the atmosphere and vary in their ability to trap heat. This makes comparing the gases difficult. So, greenhouse gas emissions are often reported by each gas global warming potential. For example, methane has a global warming potential of 21, meaning that one molecule of methane has 21 times more heat-trapping ability than one molecule of carbon dioxide. Thus, carbon dioxide is the gas we hear most about. Even minor releases of other gases have significant impacts. Some of the gases are over 20,000 times more potent than carbon dioxide, though they are released in such small quantities that they are not likely to trigger widespread warming on their own. When reporting emissions for an organization's carbon footprint, all the gases are represented as carbon dioxide equivalents, or ECO2, which translate the global warming potential for each gas into one common denominator. So it is possible to compare total emissions regardless of which gas is emitted. For example, if a company is responsible for 1,000 units of carbon dioxide with a global warming potential of 1 and 100 units of methane with a global warming potential of 21, the total global greenhouse gas emissions would be expressed as 12,100 units of ECO2, or 1,000 CO2s times 1 plus 100 methanes times 21, which equals 12,100 units of ECO2. Okay, let's take a look at the United States EPA website that has a greenhouse gas equivalency calculator, which makes it a lot easier than doing all the formulas that I've kind of been throwing together. But this is a great website. You just go to EPA and type in greenhouse gas equivalency calculator, and you should get this. This calculator was last updated March 2020. So one of the, I think, cool parts about this website is that you can just enter in a value that makes sense to you. So for instance, I put in 5 gallons. Okay, let's do 1 gallon of gasoline, and we want to know what the equivalency is for CO2. So it says here you get all sorts of information from greenhouse gas emissions. They're saying the typical car that you're using averages 22.1 miles per gallon, and you would emit 0.01 tons. You can tons of CO2, but you can also put down CO2 in pounds, which is 19.6, or let's say metric tons, 0.009, or kilograms, 8.9. Let's get back to pounds. So the CO2 emissions of 1 gallon of gasoline that from a vehicle that gets 22 miles per gallon puts off about the equivalent of 9.8 pounds of coal burn, which looks kind of significant. Let's pick another one here. 0.363 pounds of propane, or 1,133 charges of your smartphone if you use 1 gallon of gasoline. So greenhouse gas emissions avoided. Okay, so basically says tons of waste recycled instead of landfill, or garbage trucks of waste recycled instead of landfilled, trash bags of waste recycled instead of landfilled, wind turbines running for a year, 0, incandescent lamp switched to LEDs, 0.338. Okay, carbon sequestered, tree seedlings for 10 years, so 0.147 tree seedlings have to be planted for the 1 gallon of gas, and it has to be grown for 10 years. 0.012 acres of forest grown in 1 year, or 0.0001 acres of U.S. forest preserved from conversion to cropland in 1 year. So the equivalent of 1 gallon of gasoline, that's what you have. So that's a pretty interesting website. You have a whole wealth of documents you can refer to. How are the equivalencies calculated? Updates. Really straightforward, simple way to do your calculations for greenhouse gas equivalencies. Alright, well, thank you very much, and I'll talk to you next time.